Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 2 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1536. Minimum swaps to arrange a binary grid. So in this problem, you are given an n into n binary grid. In one step, you can choose two adjacent rows of the grid and swap them. A grid is said to be valid if all the cells above the main diagonal are zeros, and we have to return the minimum number of steps needed to make the grid valid, or -1 if the grid can't be valid. The main diagonal of a grid is the diagonal that starts at cell 1, 1 and ends at cell n, n. So here, let's suppose this is one grid you have, and this is nothing but 3 into 3 grid, 3 into 3 grid. And let's say for simplicity, this is row 1, this is row 2, this is row 3, this is column 1, this is column 2 and column 3. So here I can say this cell is nothing but 1, 1, this cell is nothing but 2, 2, this cell is nothing but 3, 3. Clear? So what it is saying, this problem statement is saying that this is your main diagonal, and above this main diagonal we should keep zeros only, and if it is not possible, then in that case return -1. So grid is said to be valid if all the cells above the main diagonal are 0, and the main diagonal of a grid is the diagonal that starts at cell 1, 1 and ends at the cell n, n, and n is nothing but 3 here, 3 into 3 size grid. So this is the requirement. So now let's see how we are going to solve this problem with some examples here. So if you see this example number 2 first. So here this is nothing but 4 into 4 grid, 4 into 4. So here this is your main diagonal, this is your main diagonal here. So here if you see, at this place you need 3 zeros, at this place you need 2 zeros, at this place you need 1 zero. So here if I just give the indexing, I'm giving the indexing here starting from 0, right? 0, 1, 2, 3, and this is nothing but 0, 1, 2, 3. This side we have columns, this side we have rows. So in one particular row, if you see here, we need 3 number of zeros, here we need 2 number of zeros, here we need 1 number of zero, and here we need 0 number of zeros. Can I write it like this? Since here if you see size is 4, n is 4, so this is nothing but 4 into 4 grid. Can I write it like this? N minus, this is row 0, n minus I, so it is still 4. N is 4 and I is 0, current row, and -1 is the number of zeros. Apply this formula, you will get 3 here. And now if you move here, n minus I minus 1. If you apply this formula, n is 4, I is nothing but current row 1. So 4 minus 1 is 3, 3 minus 1 is 2. And here again, if you apply this formula, n minus I minus 1. So 4 minus row is 2, 2 minus 1, 1. And again, here if you apply this formula, n minus I minus 1. So 4 minus 3, 1, 1 minus 1, 0. So 0 number of zeros we need for this row. So I can say this is nothing but, I can just pass this formula in one variable, let's say required. So required variable, it shows the number of zeros I need in one row. So here, first thing I will do here in my code, I will calculate the trailing zeros for all the rows. So in this row, only one number of trailing 0. Check from here, only 1 0, trailing 0. Check from here, only 1 0. Check from here, only 1 0. Trailing zeros I'm calculating. If here it is 1, I can't swap the columns. I can swap only the rows. Rows can move here and here like this. But I'm not swapping the columns. So if you see, if you check from the end, here only 1 0, here only you have 1 0, here only you have 1 0, here you have 1 0 only. So simply means I'm not seeing this number of required zeros for if I'm here, and here I see I have just 1 0, so I may check this row. In this the row also I don't see 3 number of zeros, trailing zeros. In this row also I don't see trailing number of 3 is the number of trailing zeros. Here also I don't see that. So in that case simply return -1. In that case simply return -1. All rows are similar, swaps have no effect on the grid. So I hope that this part is clear. So here if you see this example number 3, so this is main diagonal, and if you see here trailing number of zeros are 2, trailing number of zeros are 1, and here 0. All right, so now first I calculate the trailing number of zeros. So this step is done. Now after that I need to see how many swaps I need. So here I move to this row. I see here I have required number of zeros is 2 and trailing zeros are also 2. So no swap is required. Then I move here. Trailing number of 0 is 1 and required zeros for this row is also 1. No swap is needed. And here also trailing zeros are 0 and number of here the required are also 0. So no swaps are required. So that's it. So in this case 0 is the output. Now let's see this example 1. So here we will see how we are doing the swaps now. So first thing, this is your example 0 0 1 1 1 0 1 0 0. So in this, how many number of trailing zeros are there? 0. In this 1, I'm calculating like this from here to here. So I see 1, let's stop it. 0. I don't need to calculate this. These are not the trailing zeros. So as soon as I encounter 1, that's it. We have to stop. Here only 1 number of 0. Here 2 number of zeros. So this is the first thing that you need to do. So trailing zeros count I calculated. Now I have to check the swaps, right? So here this is what you have as of now 1 1 0 1 0 0. Clear? So now here you are here. This is, let's say, row 0. This is row 1. This is row 2. This is column 0, column 1, column 2. You are here. So at this place your I is here. At this place required is n minus I minus 1. So that is nothing but 3 is the size of this grid, n into n, minus 0 minus 1. So 2 is the number of zeros you require here. Clear? Now after that create one more variable j and just place it here. Done. Now I will see here, while my j is less than n, we have to find a row that satisfies the requirement, and here trailing zeros in this row, it should be less than required. So it is less than required. Required is 2 and here we are seeing 0. So trailing number of zeros in this is less than the required. What you need to do, move this j comes here. In this also j is less than n, and trailing number of zeros in this row is 1 and 1 is less than required. Move j down. Now my j is here. J is less than n and trailing number of zeros in this row is equal to required this time. So we have to stop. We have to stop here. Now here my j is not moving to this position. So if my j moves to this position, that simply means we didn't find any valid row where my trailing zeros is equal to required. So in that case I have to simply return -1. But now we have found one j value here. Clear this part? Now here what I will do, this I need to swap with this. But how swapping is happening here? So here you have two number of zeros in this. In this you have one number of trailing zeros. In this you have zero number of trailing zeros. Now we have to see how swap is going to happen. So what you need to do here, this value put it in temp variable, and then this value you put it in temp. Okay, now after that, what is this? This is 1. So just move it to this place. So this one is nothing but, now that simply means I am swapping these two. I am swapping these two. So if I am swapping these two, so this one is going to come here, one is going to come here, and here I will just store the value of temp. So here swap is happening. So here like this. So what I did, this value I store it in temp variable first, and then at this I'm storing the trailing zeros at this index, at this index, at this index, trailing zeros, trailing zeros. First I put in temp, and then I update this value with this one. So it is going to become 1, and now in this place I store the value of temp 2. So swap is happening here. Done. So here I will increment the value of swap to 1 1. I will create one variable swap, and swap value I will increment by 1. This is done. One swap is done here. Now after that, another swap will happen, because when one swap happens, so just move your j back to this position. Now still j is not equal to I. J is still bigger than I. Again, do one more swap here. This to this. Now again, what will happen here? This value I will store in temp, and then this value I'm going to bring it here, 0, and here I will store the value of temp, that is nothing but 2. So now in this case, again one more swap is happening, and j value becomes equal to this. So total 2 swaps happen. One is here and one is here. 2 swaps happened. But now in this case, if you see, now here in a website, this is what you have. So this is what you have. Okay, so now here I am seeing the 2 number of trailing zeros. I'm not caring about the rest. And here at this position I'm seeing the 1 number of 0 as of now, and here at this position I'm seeing the 0 number of zeros. This is what I'm seeing after this. So here if you see 2, 0 and 1, so that's what. Clear? So now this part is solved. Don't see the rest here. This example, this part is solved with my code. Now what I will do, after that again my eyes move here. Now again here at this position required is 1. Again apply the formula, required is 1. Again j start from here. So here trailing zeros is 0 and it is less than required, so j is moving down. So here we have 1. So here I have to do one more step. So this one is go here, this 0 goes here, and this is solved. Then this is already solved, so total swaps is 3. That's it. That's it. Let's write the code now. Very easy. So here code is going to be very easy and very simple. Nothing complex in the code. Int n is equal to grid dot length int trailing zeros is equal to new int n, and then what is going to be your first step here? You have to count the trailing zeros for each row. Step 1, count trailing zeros for each row. So here you are just going to run one loop. Int I is equal to 0, I is less than n, and here I plus plus, and here int count variable value is equal to 0, and then you have to just start iterating from the end. Int j is equal to n minus 1, j is greater than equal to 0, j minus minus, and here if grid value at this particular cell, if it is equal to 0, then in that case simply do count plus plus, else just break it if you encounter any 1. So in this way I'm just going to calculate what I'm going to calculate the trailing zeros at this particular row. This value is equal to count. That's it. So this is how I'm going to calculate the trailing zeros. Now after this we have to calculate the swaps. So here int swaps is equal to 0, and then my step 2 is going to be try to place correct row at each position. So here what you are going to do, you have to run one loop. Int I is equal to 0, I is less than n, and I plus plus, and here you know the formula for this required, that is nothing but n minus I minus 1. So this is the formula for required, and j value you are just going to place at this I as of now. Then you have to find a row that satisfies requirement. So here while loop j is less than n and trailing, so we have to become a little bit greedy here. So minimum swaps we need to check, right? So I'm starting from top only, whatever the minimum nearest row in which this requirement we are able to satisfy, that I'm going to pick required, and here j plus plus. That's it. And here if you are not able to find this anywhere, if j becomes n, then in that case simply return -1. So here this is for if not found. Now after this we have to bring row j to position I using swaps. So here while j is greater than I, and here int temp is equal to trailing zeros at this j. So in temp I'm storing this value, then trailing zeros at j minus, at j I will update it with trailing zeros at j minus 1, and trailing zeros at j minus 1 I'm going to update it with the temp. Simple thing I'm doing here, and every time I have to increment the value of swaps, and j values are decremented every time, and in the end here we have to just return the swaps. So this is your code. So now let's run it. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity for this problem? So time complexity is going to be of n square only. Since n size is very small, so our solution accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.